Hi guys, BuildZoid here, and today we're going to be taking a look at another DDR4 memory overclock on Z490, and this time I decided to use a kit that I'm not sure it's been featured in any other videos. It's a very unique kit in my DDR4 memory collection. It's the only G.skill B die I have. It's the only A0 PCB based B die I have. It's pretty old and it's not that great. So yeah, but anyway, here you can clearly see, so it passed, so it's just 2x8 memory configuration here, dual channel on the 10900K, of course. CPU's running 5.1 gigahertz. Don't believe Task Manager's lies. Task Manager lies about frequency. So if we pull up CPU Z here, yeah, and this, again, you know, I've stability tested this with Linpack Extreme. This is 21 loops, and each loop is about 43 seconds. So that's about 900 seconds. If you wanted full stability, you should probably run, I would run Linpack for an hour. Also, since the last video about memory overclocking on this is of course done on the MSI Z490 Unify. Thank you MSI for the motherboard as well as for the CPU. The CPU's on loan. So 5.1 gigahertz core clock. You know, past Linpack. There is a lot of V-droop on the voltage on this, on the overclock. So that voltage right now there is just idle, basically. Anyway, we're running 4533 CL19. I'm not really happy with the settings I ended up with, but this kit is just, this kit is something. Like, it's not good, but it's something. Then the Northbridge frequency here is 4500. So since the last video, I've actually managed to confirm that, yes, this has to run. The cache can't do more than 4.5 gigahertz. Not Linpack stable anyway with the voltages I want to run. Yeah, like with more core voltage, it would potentially run a higher cache clock, but as it is, yeah, no, it won't. But anyway, so 16 gig configuration, and here's the actual SPD for the memory kit. So G.skill, Samsung, it's Samsung VDI, 4600 CL19. This kit, the stock spec is 4600 CL19, 23, 43, 1.5 volts. Now, what's crazy about this kit is it is super ridiculously temperature sensitive. Like, horribly temperature sensitive. Like, I had it running at 4533 CL17 overnight, and then, well, like, I started that test at like 3 a.m. Then, because my sleep schedule is just not, like I'm back to vampire hours is the best way to put it. So, as I was going to sleep as the sun was coming up, it was still stable. I think it was at like 500% mem test, no errors. And then I woke up at noon, or a little bit after noon, some like 2 p.m. Yeah, so I woke up at like 2 p.m. and I checked back on the memory. It's at like 2000%. There's 3 errors. And so essentially, so then I was like, oh, but what I did notice was that the room was significantly warmer than, you know, at night. And so I was like, okay, let's try stabilize it. And then I spent forever trying to stabilize the kit at similar settings, and it just wouldn't stabilize. And this was at 1.5 volts. You know, 1.5 volts, 4533 CL17. So that's actually a pretty respectable overclock in my opinion. But yeah, I couldn't stabilize it because the room was warm. And so eventually I decided, you know what, let's give up on 1.5 volts, lowered it to 1.45 volts, and now it can run 4533 CL18. And now it's actually, what is it? It's 10 p.m. right now, so the room is starting to cool down. So yeah, there's no way it's going to get any more errors at this point. But basically, yeah, like the kit is super temperature sensitive. I think the room temperature was like 5 degrees higher earlier today, and that was enough to upset the whole thing. So I dropped the voltage, raised the timings, just, you know, B-die things. So obnoxious freaking kit. And yeah, if this started error, honestly, if this, I don't know that I would run it in this configuration in a daily system. And like, this is the thing, is like, you can see that G.skill's stock timings on this are terrible because they're trying to compensate. Like, the kit was originally designed to run for to be run with X299. So you can see the really loose TRCD of like 23 that is there. to help stability on weaker memory controllers like what you'd have on a 7740X or a 7640X. That's the CPUs it was really meant for. So those CPUs don't have as strong memory controllers, so you have the looser TRCD. But the other thing is like even the cache latency is freaking terrible because at 1.5 volts, like the kit is going to be very temperature sensitive. And essentially what the temperature sensitivity means is that at say 40 degrees, you can't run the same kind of settings that you can run at 30 degrees, even at the same voltage. So yeah, the solution is to just set the kit up with really loose stock timings, and then it doesn't matter what kind of temperature it hits. So yeah, but the kit is a massive disappointment. Also, it's on an A0 PCB, which you can't really, like, basically I wanted to run this kit for an overclock to see, like, you know, what if you're on eBay buying, like, old Flare X kits or something, right? Or some other old B-die kits that somebody might be getting rid of that are on an A0 PCB, like, how will those behave with the Z490 motherboard, I was wondering, and well, this kit is ridiculously temperature sensitive. I don't know if that's true across all A0 or if it's just this kit. It could just be this kit. It is a very unique speed bin for an A0 PCB. 4600 tends to be about the limit of what that PCB layout can hit. Yeah. So that's kind of the thing here, but I wouldn't feel like if I had a high power consumption GPU in a system with this, I would not feel comfortable running that. Like this kit is so ridiculously temperature sensitive, though. Yeah. So anyway, I wanted to still show the overclock here because I don't want to use all of my good kits on one motherboard. I want a variety of different memory overclock. So here we just have an example of a memory kit that's super ridiculously temperature sensitive, and yeah, like, would I actually consider this properly stable? Not really. And, you know, the thing is, it was overheating with a fan on it. Like, because the room temperature goes up 5 degrees, so the stick temperature goes up 5 degrees, and the sticks would start erroring, and it's just like, man, freaking kit right here. But anyway, like, it should, like, there are definitely kits out there that could do settings like this without the ridiculous behavior where, like, where they're super temperature sensitive. So anyway, LinPack, you know, passed. Mem tests have been running for a while now, you know, 800%. So I'd consider this, like, if I could maintain the temperature of the memory sticks perfectly stable, then I would actually consider this a stable overclock. Realistically, though, if you had a GPU in your system, it would probably make this memory crash. So this memory is absolutely freaking, like the summer would make this memory crash. Like, this is not what I would, not a great kit. So yeah, interesting kit, but not a great kit. Yeah, so far no errors. So let's just, we're gonna run some, you know, basic benchmarks on this. Also, you know, LinPack was hitting 99 degrees, so that's just there. The AIO, like, I'm still cooling the system with a 280mm EVGA AIO. And the only reason why I can get away with running LinPack, I was running the 10 gig. So LinPack has a very high peak power consumption, but the average power consumption isn't really that bad. So even with the 280mm AIO, I can actually sustain a 5.1 gigahertz, you know, full AVX stable overclock. So that's rather nice. I guess let's run Cinebench. Not that Cinebench really scales with memory, but just for fun, I want to see how this scores. So the dual rank kit, I think, did 6,666, and honestly, I'd expect this to hit about the same. Like, the dual rank, not dual rank kit, but the dual rank overclock I had in the previous video, that hit about, you know, 6,000, like, you can see that score over there. That's 6,666. So I'm kind of wondering, hey, what's this going to hit? Also, Cinebench right now is running at 80 degrees. So, yeah, like, LinPack is a lot hotter than Cinebench. Cinebench is not a very hot workload. It also doesn't, like, the thing I really like about LinPack, and I, like, especially when working with this kit, I realized that I really like using LinPack, is that it is so sensitive. Like, if the cache was wrong, it would just randomly crash the whole system. If the memory was wrong, it would crash as soon as it loaded up, like, started to try, like, tried to start doing its workload. So yeah, it's great. Like the thing you want from a stress test is you want a stress test that crashes very quickly, not one that crashes after like 10 hours, because you know that basically means you're going to be iterating on your settings on a once every 10-hour basis instead of once every 5 minutes basis. So yeah, it's very quick to sort of catch major instability, and that's why I like it. Unfortunately, it also gets really, really hot, so I'd assume a lot of people don't want to run it. So it's ever so slightly slower, but it's Cinebench. It doesn't really count. So let's run some synthetics. So Geekbench 3, or actually Cinebench is a synthetic as well, but well, like the Cinebench is based on the Cinema 4D rendering software. So like if you have good Cinebench performance, you should have good performance in Cinema 4D rendering just in general. Like that's the whole point of that benchmark, is to check if your system's good enough for doing 3D renders with Cinema 4D. Anyway, so let's run this. And when Dijkstra comes up, I always have just like a hint of doubt in my thoughts, where it's like, is it gonna crash this time? But after Linpack, I don't think there's anything that'll crash, except maybe like a more intense version, like a more intense run of Linpack that might crash. But everything else should be completely fine. Because the other thing is Linpack should actually be very heavy, like also cause quite heavy transient loading on the power delivery for the CPU. So yeah, it's like I really like it as a stress test. It's great. The only issue is how freaking hot it gets. So memory performance 8300, so significantly slower than the dual rank setup in Geekbench, but that makes sense. Like Geekbench is pretty much just a raw bandwidth test. IDA obviously has a very, like, IDA's bandwidth tests and latency tests are by like the most synthetic memory tests I'm aware of. Also, another thing I like about Linpack is it actually spits out performance figures, and you can actually, like, it is relatively sensitive to memory timing adjustments. So, like, there's a lot of things where, like, so basically, like, yeah, IDA's gonna spit out some numbers here that actually look, very similar to what the 4x8 configuration was getting, but in actual, like, other workloads that use a lot of data, like Linpack, like Geekbench is a memory test, right? Like Geekbench doesn't like this memory configuration very much. Linpack doesn't like this memory configuration very much. It's a bit slower there. So yeah, whereas IDA is like, read looks about the same, write looks about the same. I think copy's down and latency is a slight improvement. Oh, I did not realize that you could do that. Anyway, but latency is 42.5 nanoseconds instead of the 43.3 I was getting previously. So slightly lower latency, which is what you'd expect with like 4533 CL18 compared to 4266 CL16. It's a real shame that I couldn't get 4533 CL17 working. But anyway, like the thing is CL17 requires more voltage. Man, the mouse just dropped out and I thought the system finally crashed, which would have been very strange. So anyway, let's restart and go into the BIOS and take a look at the settings. Oh, there we go. So yeah, 5.1 gigahertz core clock, 4.5 ring. For the CPU settings, I have PCIe spread spectrum disabled, speed shift disabled, TVB's stuff disabled. Temperature limit is raised to 105 degrees because if your CPU ends up thermal throttling during a stress test, it'll cause some very, like, the change in the core clock will cause some very nasty transients, and that can actually cause the system to crash, even though, like, you're not necessarily running into CPU instability, you're running essentially into power delivery instability caused by the CPU changing its clock speed. So you don't want your, like, if you're thermal throttling during a stress test, it invalidates the stress test. So, yeah, like, I test with 105, like, I have it raised up so that it doesn't thermal throttle. If you had a better cooling system, like, if I had a better cooling system here, I probably wouldn't need the 105-degree temperature limit. Yeah, the 280 millimeter AIO is pretty borderline for this. So yeah, and here's the actual voltage setting. So again, 1.405 volts set voltage on the CPU, but the LLC is extremely droopy. So that gives you good transient response. CPU voltage protection 400 millivolts maxed out, current protection maxed out. Switching frequency is down to 500 kilohertz. So that proves my suspicion that the switching frequency does nothing for core clock stability. Because yeah, like Linpack doesn't care. Like I think in the last video I had it at 600. I was messing around with also 700 kilohertz. It wasn't doing anything. Same goes for the system agent voltage. I just ended up setting that to 500 kilohertz, stable. So 1.4 volt system agent necessary here. The high memory frequency absolutely requires 1.4 volt system agent. This should still be safe for long-term use, so I don't really have a problem with that. I do plan to do some even higher frequency, like memory stability testing. And the motherboard will happily default to like 1.65 volts VCCSA, which I wouldn't run daily, but like, you know, I still want to see if the motherboard can pass mem test at like 4800 megahertz or something, so I'm willing to tolerate the extreme voltages for at least the say. Like the thing is, I have the CPU on loan on MSI from MSI, so if MSI's motherboard kills their CPU, not really my problem. I would not run 1.65 volts daily for system agent, like absolutely no. CPU I/O voltage 1.32 volts. I ended up raising this, so I ended up messing around with the I/O voltage a little bit when I was trying to run the 4.6 cache, and that's sort of a leftover from me trying to do 4.6 cache. Because I/O voltage can help sometimes stabilizing higher, like basically cache. So the ring ratio. Okay, so MSI calls it ring ratio. So ring clock scales with two voltages, V-core and I/O voltage. And so I was kind of hoping maybe if I bump the I/O voltage a little bit, it'll do 4.6. Apparently not. It needs more V-core. But yeah, I sort of just left that there because it wasn't really harming memory stability by being a slightly higher, but I probably could have run I/O voltage at 1.3 volts. 1.28 is definitely not stable. I know that for a fact. 1.28 will crash even at 4.5 gigahertz ring ratio. So yeah, and then the memory voltage itself is set to 1.45 volts because otherwise the memory sticks just overheat immediately. Like the thing is the temperature sensitivity of memory kits actually, well, B-die tends to increase as you raise the operating voltage. So if you have thermal issues with B-die, the easiest workaround is to lower the voltage. Now, obviously, that's also going to take your timings down with it because your memory timings and your frequency scale with voltage. But if your memory is overheating and unstable, then, like, ramming more voltage into it will generally just make the problem worse. Okay, so, like, that's kind of the issue with cooling B-die is just, like, if it's overheating, you just have to lower the voltage. There's no real, like, workaround. Like, especially, like, well, workarounds would be if you don't already have a fan on the memory, you can try add a fan to the memory. But if you have a fan and it's still overheating, then you just need to back off the voltage, and that's what I ran into here. So here's the actual timing settings. 2T command rate. This is a 4-DIMM daisy chain motherboard. 1T command rate isn't going to work at 4533. Honestly, even on most 2-DIMM motherboards, I wouldn't expect 1T command rate to work at frequencies this high. 1T command rate generally works up until about like 4200, maybe 4300, and then once you go past that, it's just like you can give up on 1T. It's generally not happening. So TCL18, TRCD19, TRP19. So these are basically memory controller limited. They should be able to go lower, but yeah, the stability is not there. Also, actually, I think they might be a combination of both memory controller and the temperatures. TRFC is actually a 320. It's slightly higher. I don't think that actually helped, but generally TRFC is one of the timings that in theory should be really temperature sensitive. Except in practice with B-die, it to me seems like it's actually like the cast latency that really cares about temperatures. So yeah, I raised that up. Probably would work just fine at 300 as well, but yeah, like the difference between like at this point it's actually harming performance compared to like if you ran 280 TRFC, but I don't know, for daily, anything around 300. At the same time, we're also at a higher, like, at 4533, 320 TRFC is actually shorter than, like, 320 TRFC at, say, 3200 or something like that. So, like, relative to the frequency, this isn't actually that bad. But, yeah, it could probably go lower. This memory kit just like I had enough of the constant error after 70+% of mem tests, so I just kind of loosened out everything that I was like, yeah, these normally scale with temperature, so I just loosened everything out like that. 40,000 TREFI, just because that's sort of a known good value for BDI, and the thing is 40,000 actually, like, that timing gets smaller essentially as the frequency increases. So it's actually like theoretically at 4,500 I should be able to run a higher TREFI than at lower frequencies, but 40,000 works at 4,000 megahertz, so it has to work at 4,533. So it's not a concern there. TWR 16, I did try to run it lower. I think it was causing, like, I was still having shutdown issues, so I ended up raising it to 16. The thing is, I raised a bunch of timing, like, I gave up on a bunch of timings at the same time. Also, TWR at 10, which is the other value I tried, didn't really do anything for performance either, so it's just like, yeah, it's not that important. TWTR 4.8, that's like they might go lower, but most of the time they bottom out around 4.8 or like 3.6, and it's like 3.6 is not that much faster than 4.8, so I'm lazy. 4.8, way faster than XMP. On XMP we'd be looking at like 11 or like, well, 6.12 or something ridiculous like that, or, well, 6.12 is not that bad. But you might have like 7.14 or 8.16 or 9.16 or, like those timings can get very, very high on auto. So this is a good improvement over auto settings, but it's not so, like, it's not necessarily the limit of what the kit could do. TRRD 4.4, you literally can't set these any lower. RTP 12, this defaulted to 10. I ended up raising it because of the obnoxious, in like memory issues, that like memory stability problems I had, so I just raised it up, and no more memory issues, so that might have been part of it. TFAW 16, you can technically set that lower, but it won't do anything for performance, so there's no point setting it lower. TCWL 18, this is just an anomalous, like, weird thing about this board. It requires TCWL 18. Theoretically, that timing should do like 17 or 16, but this board just doesn't, like, if you try to do that on this board, it doesn't post, so yeah, there's some kind of training issue with that, and I don't have a solution for it, so I just leave it at 18. TCKE2, it doesn't go any lower, right? Like if we set it there, so yeah, 2. TCCD4 and TCCDL6, normally that would default to 4.8. 4.6 is a little bit faster. It's also stable. And for the tertiary timings, I have 7.466, which I think is auto, 8.44, which I think is basically the same as auto, but I do have this this 11, 11, 11, 11 right here, and that actually gives you a nice memory bandwidth boost. Lower than that could be stable, but I tried 10. I don't think 10 was working for me, but with some kits you might be able to go lower on those. So those give you a nice memory bandwidth boost, and generally, like, all of the tertiary timings, pushing them as low as possible will give you nice increases in memory bandwidth. Yeah, these two are on auto because they have a relationship with the WTR timings that I don't really want to deal with. So the motherboard sets them correctly, so I just let the motherboard take care of that for me. Then these two down here, which are set to 8.8, those would normally default to 9. Actually, I don't think they should affect anything, because technically that's different rank and different dim, and we're in a single rank, single dim configuration. So yeah, those shouldn't, like, those probably don't do anything, but I set them anyway. Yeah, and then everything else is just auto. So sort of like this is kind of like my autopilot BDI timings, essentially. Like, this is what I aim for in general with Intel systems, is just something that looks a lot like this, regardless of how many memory sticks or how many memory ranks I have. This is what I'm aiming for. Because this, it's not necessarily the fastest, but it's not as, like, it's better than auto, significantly better than auto, and it's still stable. So it passes all the stress tests. So yeah, and that's basically everything. I didn't really change, I've not changed any other settings here. So yeah, that's it for this overclock. Yeah, so this kit is just, this memory kit is just quite the adventure. Yeah, you're probably not going to see me running it anytime soon because, yeah, it is horribly temperature sensitive. And also it's A0, and like, it's not even, like, it's far from being the best V-die in my collection, but I wanted to play with it just because it's like, oh, it's pretty unique. I wonder how A0 would behave on Z490. It behaves fine, you know, you're not going to hit the highest frequencies with it. At least on paper, you shouldn't be able to hit the highest frequencies with it. So, yeah, like here it's topping out at 4533. If I want to go higher, I need more system agent voltage, so yeah, I wouldn't go above that. Anyway, so that is it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can buy shirts, stickers, posters, you know, the usual YouTuber merch. And both of those help out immensely with running the channel. So, yeah, if you'd like to check the Patreon and Teespring links out, that would be great. That's it for the video, so thanks for watching, and goodbye.